Hi, sir. Very good afternoon. Myself, Sheikh Sadiq from Industry Relations Department. So, first of all, thank you so much, sir, for accepting our invitation and coming here for the session. And here are some of our EC department students who wants to interact with you regarding today's guest lecture, sir. Fine?
Definitely, yeah.
Yeah, thank you, sir.
Hello, sir. Myself Sheikh Aman sir from AC department third year. Sir, can you explain how IoT and AI shapes in future in embedded systems and mechanic devices?
Comes to IoT, the best example I would give is, wearable devices. Right? Wearable devices. So you can see that includes pulse oximeter and different sensors, right? So you can watch them online. So internet is just a medium that transfer the data, but still there is electronics that integrates with different sensors. But when it comes to IoT, the data that you have, that is not offline, that is not online. So to convert that offline data into online, so where that IoT comes into picture. Similar way, there are many devices in the medical industry where you can see the data, watch the data, and then suggest some inputs. I mean, for example, any doctor, he can take the data online and then extract. So that how it helps the user and I mean the patient and the doctor to access data very simple.
Hello, sir. Myself, I am Namita from EC department third year. Now, the students who are interested to join embedded systems, how can you guide them to pursue in through medical sectors, sir?
Actually, when it comes to electronics, be it a medical or defense or aerospace, different domains, but still, the moment you focus on basic electronics, that's where it is very important. But yes, when it comes to medical, it is very, very important because you're going to handle a patient. The device which is going to control, it is controlled for the patient. It is safety basically. So you should be very well know about the safety protocols. For that, we do have many regulatories. For example, if you want to write some code for medical devices, software, that should be compliance with IEC standards. There is something called International Electrotechnical Commission. It should be qualified for that. There is some standard called 62304. So whatever you write on a microcontroller, that should be a compliance to standards. It's similar way, there is something called risk management. So before you design, it is very important that you qualify all the safety features.
Students who are interested for taking in the projects internship, what can you suggest them, sir, for embedded systems?
See, in your college itself, so you should be more practical. You should have more practical knowledge. So that's what I suggest. Like in labs itself, you start doing some basic, I mean, simple projects like interfacing some LCDs, LEDs, motor drivers, different transducers or sensors. That you should start doing it on your own in labs itself. When you do in college itself, that becomes easy when you go to industry, and that gives you more confidence to face the interviews also. So you start doing it including protocols, as I told you in the session. So you should focus on protocols, all the serial protocols. So when you go through all this protocols or basics of electronics like analog, digital, that's where you become expert. So you go to any industry, this is what very, very important.
Sir, can you explain the key role of software in embedded systems, sir?
So the software, when it comes to embedded software, when it comes to medical device, it is really, really important because you're going to deal with patient. So before even you write a program, you should be well aware of all the cases, like be it a pass case or fail case. If something is, if you're going to drive something, but what if not is not what not expected, the results are not expected. So what is the other way? You should think yourself before you write any program. Instead of looking at always at pass, you should look at fail also. If this fails, what is my next way? If this fails, what is my next way? So I should protect patient. Basically, if you focus on code, which should not fail at all. There are some fail conditions that you should predict before you write a program itself. So that actually in medical industry we follow a risk management. Before even we start design, we should write all the scenarios like if this fails, what is my next step? If this fails, what is my next case? There are some conditions called single fault conditions. That is emergency case. So in any way, I should not make patient to become emergency. Even if it is emergency, I should have another way to protect him. So your embedded software is playing a major role in controlling all control systems.
Thank you so much, sir.
Oh, thank you, Manoj Kumar sir, for once again for your valuable time and as well as your words. So looking forward definitely to work together, sir. Fine. Thank you, sir.